is Marc-Antoine and I'm a first-year student at Ecole Centrale de Lyon, which is a French College of Engineering. In parallel with my training, I'm a member of a racing car team called EPSA, whose goal is to design within 2 years a racing car whose objective is to participate to the Formula Student. My role within this project is to design the man-to-machine interface and the onboard electronics. Well, the department in charge of the motorization had to solve the issue of the size of the intake. The high number of variables that could influence the filling or the exhaust of the engine led the department to use a modeling software. We decided to modelize our engine with an LMS Amesim model. We wanted to simulate the acoustics of the engine, more precisely in the intake and exhaust areas. So we realized two models, a 0D interior engine model and a 1D model of the pipes. We used several libraries, but mainly we used the IFP and IFP drive and IFP engine and CFD1D libraries. And thanks to this LMS Amesim model, we could predict the performance of our engine and thus the performance of our racing car.
My name is Mazen, I'm a member of the EPSA and I'm also in charge of the design of the intake system of the engine. What we wanted to do is to design the intake system of the engine from an acoustic point of view. We have noticed that we have an overpressure when the intake valve closes itself. That overpressure goes right back to the intake manifold. Then it goes back to the intake valve. What we wanted to do is to have that overpressure right at the same time when the valve opens itself in the next cycle.
My name is Thomas and I'm a first-year student at the Ecole Centrale de Lyon and I'm also a member of the EPSA team. Currently I work on the car-to-ground system and more specifically on the double A-arm system. In the use of LMS Amesim, the EPSA team particularly appreciated the graphical interface. A lot of software required time in order to handle them properly, which is not the case with Amesim. Besides, the high number of models included in the software allowed us to make our first simulation very quickly. And once the handling phase is done, it was also very easy to improve our models in order to get results closer to reality. With LMS Amesim, we can also create models of physical phenomena that the team doesn't master very well. Before, the solutions that we were used to using required us to fully create the model and as a consequence to fully master the physical phenomena involved in this model. So with the same amount of knowledge, LMS Amesim allows us to create models from more complex physical phenomena. LMS Amesim simulation gives us a better understanding of physical aspects that will be studied in lessons of our curriculum. So I think that for us, its pedagogical aspect must be highlighted.